Welcome back to the last video here in this tutorial series. We're gonna have a look at how to load a model into a different project. So we're gonna create a different project, load the model and apply it. So you're gonna see the result of your trained model in real life in eCognition. Again, the results are heat maps. Okay, so you're gonna get a raster for each class. Afterwards, we're going to classify our image based on the output of the CNN. And then I'm going to show you how you easily can improve the classification using simple object-based image analysis workflows. I'm going to show you how to use thresholds to discriminate forest and non-forest and simply improve the classes that you retrieve from the CNN. And this makes it actually highly valuable because you're combining CNN deep learning functionalities with object-based image analysis. And you will see that using OBIA with CNN will improve your final classification drastically. So let's have a look at our project. Here it is. So the last thing we did was saving the CNN, and we saved it to the workspace directory because we didn't change the output path. Right, and that's by default where it's gonna be saved. We saved the project, but I'm also gonna quickly save the rule set here. You simply can click save rule set, and that allows you to also load it into different projects, and also you have a backup. I'm again gonna save it in the CNN data folder where we have our data from. I'm gonna call it CNN LCC rule set and hit the save button. And now the rule set is saved. So I always can go back to this state of the rule set, which is nice. What I'm going to do now is close the project. You simply can close this project via hitting this X button here. So not the top one, that's going to close eCognition. This one's going to close the project. Was modified, so the project was modified. Do you want to save changes? Yes, why not? And then I am going to create a new project where we're going to apply our model. Okay, so this is empty. Let's have a look at data management layout. You see we have one project that we called train. Now I'm simply going to use drag and drop again to create a second project, which will be the subset apply. The data is in the CNN data folder. Let's navigate there. So I'm simply going to drag and drop this apply TIFF into the project, and also what we have here, the NDSM subset apply TIFF. I'm gonna drag and drop that also into the project. Then we have this ground truth apply. This is used to do the accuracy assessment of the classification in the final step. So I'm also gonna drag and drop this into the project. Gonna close this one. Now you see we have a second project. What you need to do is rename the aliases here, so they correspond to the other aliases in the other project. And that's important because the algorithm or the model is going to look for those layers to apply the model on. And if they have a different name, it can become messy. Near in capital letters. And the layer 5, that's a new one. It's an NDSM, so we have elevation data in our project. And this is going to be our validation vector layer. Good. Save this project, and for this tutorial actually we're gonna create a subset of that subset apply, so the algorithms run faster and you don't have to wait so long. What you can do actually is you have this workspace tools and you can choose this define rectangular subset functionality. So if you zoom out, it's quite a long stripe, and I wanna simply maybe choose a third of it. So I'm gonna choose this one, and now you can draw a rectangle around the area that you want to create a subset from. You see the orange bounding box now. If you right click, choose save subset to workspace, it's gonna create a new subset in the workspace. So it's gonna create a new project, and it's the subset of the supply. Don't change the settings here. And now it's gonna create another project here. I'm gonna open this one, and that's only the section here that I created a bounding box for. So let's go to the rule set development layout and start creating our rule set. Actually, what I want to do is I want to load the previous rule set. So I create one rule set that does the whole thing. So let's load the rule set that we've saved previously, CNN LCC rule set. So we stopped at saving the rule set. Now in this project we need to load it. So I'm gonna create a structural process, call it load model. And then we have an algorithm simply called load CNN, where you don't have to change anything because it also points to the workspace folder, this model, so the default folder, and that's where we saved our model. Load it, so we've loaded it, and now we can apply it already. And again, applying the model results in raster layers. So we have to look for the apply CNN. Now it's important that you remove the NDSM because that wasn't an input for the creation of the model, for training the model and the sample, so RGB and near infrared. And now it's important that you define the output layers here. So for the class bare soil, please create a layer called HM bare soil. HM in this case stands for heat map. That's gonna be an output layer of the model which represents the heat map of the bare soil class. And I'm gonna do this for all the classes that we've trained the model with. And now that we've done so, you can execute it. If you do it on the whole subset, not the subset, it's gonna take a bit longer because it's just more data to work on. That's why we created a smaller subset. But if you have time, run it on the big one, and you also can work then with the results the same way as we do here. Okay, so it took almost 5 minutes to apply the model onto the subset. I think if you apply it on the larger scene, it's gonna take probably 15 to 20 minutes. Just give it a try. And you should have noticed that we now have more layers here in view settings. These layers are the output layers of our CNN model. And again, these are heat maps. Best way to see what it is I'm gonna choose the split window. So on top you see RGB. I'm gonna choose swipe view. And at the bottom, this is the heat map for bare soil. So if the model thinks this is bare soil, the pixel's gonna get higher values, right? So they appear white here. If they are black, they have lower values. We also can quickly adjust the stretch here, this one, and change the colors. Blue means low and red high. So everywhere where you have a bit of soil signal, you should have higher values here in the output. And that looks pretty good, I would say. And the same is true for, let's go to the next one. Forest. Gonna adjust the stretch. So again, the value range is between 0 and 1. High values here correspond to forest. If it's red, the model thinks it's forest, and that actually looks pretty good. Okay, but there are gonna be some misclassifications, right? That's probably just because the samples were not good, the model was not good, so you could go back and test this. We simply gonna stick with the results that we have now. What is this one? Grassland. So high values correspond to grassland. That also looks pretty good. Next one is man-made, so urban areas or roads as well. It's gonna be also probably a mixture with bare soil. Ooh, but it looks good actually. So you see roads and buildings appear bright, so red in this case. So that's gonna be helpful. What I just noticed is that we might have issues with shadow areas. See here the shadow of the forest, which is highlighted here. Actually, I think to improve the model or the results here, it might make sense to also introduce a shadow class. But we can try to eliminate those errors in the object-based image analysis workflow. Also the coastline here at the edge, this is recognized as urban or man-made, but that's gonna be an easy fix in the rule set later. Last but not least, let's check the water. Okay, that looks promising. Right, we have a few hotspots here in the urban area. So very small spots, they're recognized here as water or have a higher likelihood of being water. Okay, but now we have these layers. How do we get a classification out of it? What we need to do is creating image objects and then classify the objects based on the membership to the certain class. Okay, that can easily be done in eCognition. We're gonna use the class description to do so, and we're gonna classify image objects into the class with the highest likelihood. Okay, so let's implement this and let's see what the result looks like. So we're gonna start our object-based image analysis workflow. So we're gonna create image objects. And the first thing we're gonna do is a segmentation. That's gonna be inside here. And we're simply gonna use a multi-resolution segmentation with only the red, green, blue, and NDSM layer. So we're not using the heat maps, and the scale parameter is gonna be different as well. We will change it to 20. Thematic layers, nope. We don't want to use thematic layers. And that's gonna be the setting. So we're gonna create a level 1 using RGB, near infrared, and the NDSM with scale parameter of 20, leave the rest default, and just go. This is the result of the multi-resolution segmentation. Let's unsplit the view, and you also can change the outline of the objects, right, as you like. And you see we have a nice segmentation result. Now we need to label those objects. So those are unclassified, and we want to use the information that we created based on the CNN, right? So these layers here. And what we can do is simply define a membership function here in the class description. For example, for bare soil, double-click bare soil, double-click on this and min, and here you can insert an expression. We are looking for the bare soil for this heat map bare soil, which you can find under object features, image layer, mean. If it doesn't pop up here, right-click on the create new mean and click create for all layers. This will create this feature for all layers you have in your project. Now I'm gonna look for HM soil, and then you have this membership function here that you can define. What we need to do is define the left and right value here, and also the curve. So we're gonna go for this linear straight line. And this means that if this layer has a value of 0, the likelihood of this object belonging to the class is very low, more or less 0, right? The higher it gets in this range between 0 and 1, the more likely it is to belong to that class. And we're gonna do this for all features that represent our heat maps for all classes. And then eCognition will automatically classify the objects based on the highest value that it finds in this feature. We need to repeat this for all classes. That one was the bare soil, okay? Close. That's the membership function. Okay, now we have to go into forest, double click here, look for the forest heat map, that's important. Choose this membership function 0 and 1 here. Okay. All right, let's go ahead and do it for all classes. All right, so now after having created those membership functions in the class description itself for each class, we can now display the value for each object in the image object information window. To do so, actually, you have to look into the image object information window, go down here and choose the tab classification instead of features. So the features are the features that we've displayed for these image objects, right? The mean value of the heat map area and the variable angle, which is a global variable. If you now go to the tab classification, you actually see the certain value that is based on the membership function that you have defined in the class description. So this patch here, the likelihood of that being forest is 76.3%. And this object also has a certain likelihood of being grassland. And that is now true for all objects, right? So this is grassland. It's very sure about that. What's this one? Bare soil, bare soil, bare soil. And that is man-made. That's hopefully water. But you see some confusion with man-made somehow. Okay. And actually to defuzzy this information, we can use the classification algorithm. And that one simply looks at the highest value in that list for each object and then assigns a class to it. Okay, so how do we get our objects classified? Let's simply use the classification algorithm. So I'm going to create a new structural process here. Insert a child, and we're looking for classification. All you need to do here is change the active classes to the classes you want to classify, and this algorithm looks into the class description here in the class hierarchy and applies it. Hit execute, and then all image objects gonna be classified. This would be the initial result, classifying our scene based on the output of the CNN. But actually that doesn't look too bad. So I'm going to show you how to improve that easily with simple object-based image analysis workflows using thresholds, assign class, and so on. So let's have a look how we could improve this classification. Okay, so what I'm going to do first, I'm going to create a backup map where my results going to be stored, so I always can go back and check the results against this classification and also get my initial objects back. So you can use the copy map algorithm, and I'm gonna create a target map. So I'm gonna call it backup, and that's simply gonna be another map in my project with this state. And I'm gonna keep on working on the main map. What I'm gonna do on the main map is I will first of all calculate some index layers, which will help me to improve the classification. And I'm speaking of, for example, the NDVI, the NDWI, and the SI. That's the layers that I'm gonna compute. So first the NDVI, red and near. You have to find those. Where's red? Here, and near and far red, this one here. And this algorithm is gonna create a new layer in the view settings. I'm going to show you that in a second. First, I'm going to also calculate the NDWI and the NDSI, which supposedly should help to discriminate soil from non-soil. So let's see if that helps. So you see these layers have been created. Just going to quickly display it. This is the NDSI. This is the NDWI. Positive values for water, lower or negative values for non-water. And probably you're aware of the NDVI, the normalized difference vegetation index. High value for vegetation or healthy vegetation, and low values for non-vegetation, right? Like these buildings, negative values. And the forest should have positive values. Water also very low, negative values. And they all range between -1 and 1, those index layers. And they're gonna be helpful. Okay, so we did a segmentation, we classified based on the heat maps, we created the backup, and we calculate the index layer calculation, so we can start actually working on our objects and improve the classification. And what we're going to do now is so-called knowledge-based classification, so you using your expert knowledge to improve the classification. Knowledge-based classification. What I'm first going to do is a copy image object level. That will help me to see the changes in my objects, right? If I change the object, so I'm gonna copy my level 1 to one level above and call it level 2. And I always can go back to level 1 and see what has changed, okay? So I'm gonna create level 2 and I'm gonna work on level 2. First thing we're gonna have a look at to improve is grassland. Okay, let's zoom in and check the outlines. So it could be actually that areas have been classified as forest, like this one, but they have they are clearly grassland, right? So how can we get grassland improved? We can use the NDSM information, for example. So I'm gonna insert a child here and use simply the assign class algorithm. And I'm looking at the class forest. If forest has lower elevation in the NDSM than 1, if this is true, if you're classified as forest and lower than 1 meter, I'm gonna put you into the class grassland. Execute. And you now see that this has been classified as grassland. The cool thing now is about the 2 levels that you always can check back. So this was before I ran this assign class, and that's afterwards. So it actually already improved. And now a logical improvement would also be using the NDVI. So if you are classified as grassland, but you have a very low NDVI, you're probably not grassland, you're probably background. So where's my NDVI? Has not been created yet. I'm gonna do it. If you're lower than 0.1, then you're probably bare soil. Okay, let's go for this one. And that also changed something. So you see 2 simple steps, but that already had a great impact on the classification, as you especially see in the forest area. So a simple knowledge-based threshold. Let's in next step improve forest. So I'm simply going to copy and paste this improve grassland, rename it to improve forest, and I'm now going the other way around. So if you are grassland and you have an elevation greater than 1 meter, you are forest. Hit execute. And I'm also having a look at man-made. If man-made has a high NDVI, then it's also forest. That worked quite a bit here in this area up here. That's probably shadow. Yeah, so that helped. Shadow, that's now was classified as man-made, but now is included in forest. Perfect, so this is working smoothly. Let's have a look at bare soil. Simply again, simple rules, bare soil. If you have, now we're gonna go for the NDVI. So if there is some vegetation on it, indicated by the NDVI, I'm gonna put you into the class grassland. And then the other way around, grassland, we're gonna use the NDSI, the soil index. If you're a patch of grassland and you have a high NDSI, you are bare soil. Execute. Domain is empty. Okay, so it actually doesn't find 0.1 was too high. I need to go to 0.01. So if it's slightly positive, and then it's gonna change something. Okay, that looks better. And now you see the differences that we've made. It already looks better, I would say. Fairly simple. Okay, now actually we could continue here. Improve water, improve man-made, and so on. I already did it for you, so you can develop your own rule set, but just to speed up this tutorial a little bit, I provided you the rest of the rule set that I created. I went a bit too far, I would say. So I couldn't stop, it's just fun working with eCognition. So you can right click here, load rule set, and choose this OBIA improvement section 2. Gonna drag and drop it here into the knowledge base classification. And the next step that I'm doing here, actually updated the classes. So I'm using more classes here in my section, so it loaded them here and also updated the colors. Let's go in here. So what I'm doing here, I'm improving water, man-made, and so on. I introduce shadow. I do object reshaping, improving the outlines of the objects a bit. And then I classify forest into more subclasses. I'm quickly going to walk through it. I'm not going to explain everything in detail. That would just take too long. But you can have a look at the rule set and explain it yourself. So improve water. I'm doing more or less the same as previously, using a sign class, and I'm using the NDWI to discriminate water and non-water. And the main goal is here to improve the coastline. Let's display the outlines of the objects. And yeah, if we only display water, you'll see that some objects, I think they belong to water, and they are currently classified as man-made. So I'm simply going to execute those step by step. I'm growing a bit the water surface. I'm converting objects that are classified as man-made and have a high NDWI into water. I'm adding enclosed objects to the class, and then I'm gonna merge the object, right? So that already looks good, but actually, if you look at the outline, I noticed that it included now a lot of the beach area, the coast, and let's execute the next one as well. I think that doesn't do a lot. That includes, again, surrounded water objects, and reclassifies those. So again, yeah, the coastline, it doesn't look perfect. So what I wanted to do is, or improve water shore, what I'm doing here is actually I run a unsupervised classification only within water, and then classify it into two classes, and that nicely helps me to separate the beach area here from water. I'm simply going to execute the improve water shore section, and then let's see the result. That should look fairly good. Okay, and this is the result. So it improved the coastline. It also introduced some errors here. Could be boats, stuff like that. But again, we're gonna take care of this in a later step. And also we're gonna remove these small water features that are probably shadow areas. But yep, that improved the water outline here. Now next section, improve man-made. Fairly straightforward. Let's display man-made. There's still quite a lot of misclassifications in here, so I use the NDSM to classify buildings within man-made. Then what am I doing here? I'm adding areas of bare soil and grassland that are touching actually buildings and have low NDVI and have a high NDSM. If that exists, put it into class building. In this subset of the subset, it doesn't exist, so that's why this error message pops up. Simply ignore it. If you run it on the whole scene, there are probably objects that fulfill this criteria. And then I am using again a sign class and simply say if you're man-made, so it's dark red, and you're 100% enclosed by a building and you're fairly small, you're also a building. And that improved the building. So now this red, bright red class is representing my buildings. So all these little things here. I'm introducing shadow. I saw that we do have some issues with shadow, right? I think that's especially in area. You see the shadow here, very distinct. That's classified as man-made. So I tried to somehow improve that and classify it as shadow. I stopped at one point, but I think it might make sense to include this in the CNN and classify it beforehand. Object reshaping, I'm doing a merge. We do have fairly small image objects, right? Simply merging all image objects together on my level 2. Again, the advantage of the different levels is that you still have on level 1 the small outlines, okay? Reshaping, I'm using the pixel-based object resizing to grow and shrink certain classes and objects based on certain conditions. This works on pixel basis, and you can grow and shrink specifically. So you see the outlines have changed quite a bit compared to what we had initially. Then I do another merge because we now created objects here like this one that share the same class, touching each other, but belong to two objects. Okay, then remove objects. I am removing small trivial objects that I think are not necessary. You might have a minimum mapping unit for your project, but that's simply what I'm applying. So you see I'm fairly generalizing my results, and then I'm applying another merge. Okay, last but not least, this forest classification into subclasses. I'm only looking at forest, so I'm using an algorithm here that creates classes by default. You already have them in the rule set now, low, medium, and high. And then I'm using the multi-threshold segmentation, and I'm telling eCognition, look into the class forest and use the image layer NDSM. If it's lower than 5 meters, put it in the class low. If it's between 5 and 10, put it in the class medium. Higher than 10, class high. Execute this, and then you have your result. Okay, now we can actually compare this to the previous results that came out of the CNN, so this membership functions. What I have to do, I use split view. Up here is my final classification here that we did. And in this window, I'm gonna display my backup. And again, the backup was, we have to use side-by-side view. So up here is the main map with my final classification. And at the bottom, I'm gonna display the result, the initial result from the CNN. And you see, I think the result of the CNN, they work quite good, but improving it with a few simple rules in eCognition creates quite nice results that you see up here. And easy improvements like this forest patch, which had no elevation, simply kicked it out. And this would be my final result here. Now what we can do is an accuracy assessment. That's going to be the next step, and then we're going to export our results. Let's try to do the accuracy assessment quickly. Alrighty, so we do have a validation data set here, right? In this case, polygons. And what we need to do is we need to convert the validation data set, so these polygons, into samples, and then have the samples on the same level as our classification, and then we can use the accuracy assessment tool to create a error matrix. You simply can load a rule set that I've created, which is called accuracy assessment, that takes care of it. So what it does, it cleans up the level 1 and removes the classification. Then does a vector-based segmentation, so it's using the validation vector for segmentation. Then we use an assign class based on thematic layer, and then we convert the classified image objects into samples. The next section, we are copying actually the classification from level 2 to level 1. So we have the same classification as on level 2, exactly the same. However, I only copied forest, so not the subclass of forest, because in the validation data set we only have the class forest and not the subclasses. And we're gonna compare our classification here on this level to the samples which represent the validation data set. There's a warning, so if you execute the whole thing, only this warning will pop up. Please open the AA tool, accuracy assessment tool, under tools, accuracy assessment. So let's do it. Accuracy assessment. Make sure you choose level 1 here, then error matrix based on samples, and simply go on show statistics. And that gives you the accuracy statistics for your classification. Good, so last step, export the results. I'm gonna simply close it. We will export it as a shapefile. So simply use export vector. Where is it? Export vector layer. Choose the classes. Change the type to polygons. Add any attributes you like to the export, and we need to choose level 2. And now execute it, and that will create a shapefile in the workspace directory, right in the results folder. So let's check the result. Here it is. So it has the name by default of our project, and that's the shapefile with our final classification. Okay, good. So try to also implement that in your project if you want to use CNNs. I didn't go into detail a lot, but this is workflow, and I showed you, or I talked about basic principles that you should follow. Please do so. Try using it. Show us your results, and I'm looking forward to see what you guys are coming up with. Have a good day and goodbye.